Our first presenter, John Busel. His presentation is a state-of-the-art composites technology. John is Vice President of the Composites Growth Initiative at the American Composites Manufacturers Association. He has been with ACMA, that's the acronym, for over 18 years. He has led composites industry programs in market development for infrastructure and construction for over 25 years. And he's very active, and I will emphasize very active, in codes and standards development, and promotes composites through education and awareness to engineers, architects, owners, and specifiers. Yesterday, we were doing a lab tour in the Composite Center, and I saw John, and I used the opportunity to also ask him questions on a technology we're considering here at the university, and giving great information. John is always a fantastic resource. So if you can reach out to him after the session with any questions on the industry. During his 35 years of experience in the industry, he has done work in market development, composite design, tool engineering, manufacturing, and research and development of thermoset and thermoplastic composite materials. He's a fellow of the American Concrete Institute, the ACI, member of the American Society of Civil Engineers, ASCE, Society of Plastic Engineers, and ASTM. He was the chairman of a very important committee from ACI, Committee 440 on FRP reinforcement. He's also active in standards and development. Most recently, he has been active in the new ASC standard on FRP pull-through sections, released very recently, I believe done in May, correct? Or approved, I mean, in May. That's a correct word, yeah. He has been recognized by ACI for distinguished service, is chair of the SPE Composites Division. And in 2019, he was the recipient and inducted into the ACMA Composites Industry Hall of Fame. John holds a BS in Civil Engineering degree from Bradley University. And welcome, John, to this point.
Good afternoon. Did everybody have a good lunch? Good. I'm going to try to provide a lot of energy in mine, so we all don't go, wow. You know, everybody's getting all filled up. So thank you very much. I'm going to touch on a couple of things related to advancements in composites technology as it pertains to transportation infrastructure. So let's get started. I'm going to cover some of the product and technology advancements that has taken place. Most importantly, the complementary work on standards development that has made a lot of that happen. We're going to talk about sustainability initiatives and the importance that is going to be for the future, and I'll conclude. So when we look at applications of composites, what I find very unique is that within my career, after coming out of the aerospace industry and getting introduced to composites, although my background is civil engineering, I got to see the development of everything that you see on the left, and was involved directly in most of it. And from an association standpoint, bringing together partners to develop these products. And it's all about lightweight, high strength, corrosion resistant materials to solve infrastructure problems. And it's always about modular, factory made, lower installation costs. These are all the benefits that we've used to educate end users of composites about what we can do. But you can see this is pretty diverse, everything from structural to non-structural and everything else in between. So it's been fun, but it takes a village to do all of this. So don't think it's just about any one person. So it all started off with concrete strengthening, right? There are 10,000 installations where composites have been used to strengthen piers, bents, columns, upgrades, seismic. So this was kind of like the first installation of technology. Today it's commonplace. No one asks the question. It's a given. We have guidance, we have designers, we have very experienced personnel, both in industry as well as in structural engineers that know how to do this. This is wonderful to see such a mature part of the industry. Prefabricated pedestrian bridges, first being all pedestrian bridges, but even something, and I'll talk about this in cantilever sidewalks, where fast installation was the big deal. So when you look at this particular installation, this is the highway going to Dulles International. They had to shut down an 8-lane highway for 15 minutes to install this. They couldn't do it unless it was made out of composites. So it's that fast installation. Looking at bridge decking, very much involved, and this is where Roberto and I, back in the day, were involved with this. Developing structural shapes from pultrusion that provided unique applications, and they were most applicable to movable bridges as well as restoring historic bridges. So a couple of examples of those, and that continues to today. Cantilever sidewalks, adding a structure to an existing bridge. So it's all about lightweight, providing the ability to have pedestrian and bike access has increased across the country exponentially. And we could do this very easily as long as we specify those components correctly. Very much a part of University of Maine and the concrete filled arch girders. This has now become commonplace. Although it's not in every state, it's getting there and it has its unique application. But it also led to getting standards with concrete filled tubes for AASHTO. So that was very important. And we're going to talk about a little bit later, the tub girder, very much an iconic success story, providing another tool in the toolbox. I'm not going to touch too much on this. Rebar. Rebar has taken one heck of a journey, and it's always been on the leading edge of things as being accepted, starting from a state-of-the-art report to the first design guideline, going through 3 iterations. But the success here is not only providing a corrosion-resistant alternative, it's also providing worker safety. And as you see in a couple of pictures here, you can't take number 8 rebar, 4 or 5 bars, one person carry it the length of a bridge to go place the bars. And they have found that this is like the biggest key element as to why contractors really like this. They can install things much quicker than they could with alternative materials. So there's many other installations, and taking that technology and applying it to flat slabs, cast in place caps, precast panels, even pre-stressed piles. So now we're starting to think about all the different elements that go into a bridge dealing with concrete. So we're taking the baby steps, but now looking at holistically what these structures can be built out of. So, in the advancements in materials, we see basalt fiber. A couple of people are going to talk about thermoplastic composites and field bending. There are other resins other than vinyl ester resin that are being considered for rebar materials. And with all of this, standards are coming, and these standards are allowing the tools and the instruction as to what end users can do. But the other big thing is the business standpoint. What we have seen over the past couple of years is that those who are specifically manufacturers for rebar, they're scaling up, they're increasing the rate as to what has been done before. They're expanding their facilities, they're building new facilities in different parts of the country, which is very exciting. And they're also looking at their equipment, modifying the equipment, making it much more efficient. So there is a business case here that always needed to happen, but growth needed to happen a little bit first before they would make that decision. So this is very, very optimistic. And that's why you see so much about fiberglass rebar or FRP rebar. And then came the FRP rebar code. And I'll tell you that this was one heck of a journey that took a village. And the development, the writing of this took about 4 years, being very, very specific because it's a dependent code. So 318 is the concrete building code. This is written chapter, verse, and every subscript available from 318. It's just then applied to FRP. So it's seamless for those that are very familiar with 318. And the nice thing about this is that it has been accepted by the 2024 International Building Code, the Model Building Code. And that is a big deal. So not only did we make a code document within the concrete industry, it's also now in the building code itself. This now opens up opportunities. So when we look at the code, there's a lot of things it covers, and there's a couple of things that it doesn't cover. And some of the things that it doesn't cover doesn't mean that we're ignoring it. It's just that the research hasn't caught up with everything that is there. But it's still a very useful document for most concrete building element applications. And then along with that is all of the complementary documents that go along with it. So these are the other tools. So this construction specification is written like ACI 301, and it provides the contractors with the information that they need so they know how to use and place the materials. And of course, always helpful, getting a design example handbook that is complementary to the code document. So this is currently being under development by ACI. I suspect it's going to be finished by this year sometime. It covers very good fundamental examples of how to utilize the code. So it's one thing to read it. It's also another thing to read the commentary, but to know how you work through the examples is a big deal. So expect that one. Come on, there we go. Now, this is the document that started all of this. This is the design guideline for FRP rebar. One of the good things about this is that it has gone through several iterations. It still is a state-of-the-art kind of document. So there are things that are not covered in the code, but this document does cover. So everything is complementary, but a lot of the guidance is really there. And then we have the godfather, if you will, of all product specifications, D7957. And it covers how to test and to evaluate various different components that are out there. Future work is here, higher modulus bars, along with basalt fiber and thermoplastic composites is coming right around the corner. So there's always an evolution. And then we have the pedestrian bridge spec. So ACMA and our Transportation Structures Council Tiger team, if you will, is working on the update to this 2008 document that we worked with AASHTO to create. And it does a lot of different things. Come on, there we go. It was based on the truss style bridges, but there's been a whole evolution of other types of composites and products that have been out there, including pultruded decking and sandwich construction that has been molded. We're going to do much more with connections. We're going to get much more in detail with overlays, joints, and drainage, and even cover inspection guidelines. So it's a really major upgrade to what was there before, because this is an important document for bridge engineers. And as Roberto had talked about, the ASCE 74 document, this is everything about pultruded truss type profiles, and it's finally been approved for publication. We're currently going through the formatting of the document, should be available. So this is going to be a major guide written in LRFD. So when you look at the other AASHTO standards that are out there that you could tap into, here's the laundry list. But I want to point out to an update, second edition, that was done in 2023 for FRP bonded systems. So everything I was showing you in the very first slide with concrete strengthening, we're now going through evolutions. And knowing that things are now out of first edition, becoming second edition, it's starting to become very real. Sustainability is a big thing. Last year, the Biden administration talked about environmental product declarations and how we have to be reducing the life cycle emissions of our constructed structures. And then everybody started asking, well, what do we need to do here? So now we're getting into a whole new challenge for the composites industry. How do we develop the life cycle inventory data that is used to the life cycle cycle assessments, which is then translated to the product category rule, which is the standard by which environmental product declarations are written. And those environmental product declarations are going to be utilized by building and construction authorities to evaluate a material and a product against each other. And certain states like Colorado have a state law that unless environmental product declarations are in place, they are no longer going to consider those materials for their building and construction. So we have a timeline that we have to speed up and get work done. So when we talk about, and Joe's going to talk a little bit more about this, you hear the words cradle to gate, cradle to grave. These are important facets of identifying what the sustainability of the materials are. And as a composites industry, we're good or just okay from cradle to gate. Where the composites industry and its products will launch and leap and be a huge benefit is in the use phase. But documenting what goes on in the use phase, which is a part of durability and how long it lasts, is a major accomplishment that our industry needs to be working on. So what is ACMA doing today? We're working on a product category rule for FRP rebar. We're also doing a PCR for utility poles, so something a little bit different in infrastructure. And we're going to be working on a host of environmental product declarations that will help start the process to educate our industry. Working on LCAs, which is an important thing, but that's a very complicated, but we need to study the in-use phase of composites and compile what our industry can do. Boy, this thing is temperamental. So advancements in materials continues to evolve. We're always going to see this each and every year. There's a lot of new standards that are providing tools for engineers to utilize. And those engineers that have utilized composites are seeing success, and there needs to be more of that. We have a need to educate young engineers. Businesses are expanding, and this is a good thing. Sustainability will be our biggest challenge, and we'll see more of that in the coming years. And capturing and characterizing the use phase is the most important thing that we can do. So with that, I'm done.